Hello Bearcats, welcome back to some more Calculus FRQ fun with me, Mr. Stebbins, attempting to explain these complicated problems over the internet. So here we go. What could go wrong? Hey, it's 2016, that was a great year, and this is FRQ number 3. So this is a classic, I'm going to give you a graph, and then I'm going to make the function the integral of that graph. And then I'm going to ask you all kinds of questions about maximums and minimums and positives and negatives and second derivatives and all that stuff. So this test question is basically testing your ability to relate how the integral and the derivative relate to a function. And if you know that the integral of a function is the area under the curve from whatever point they talk about, then you'll be fine. So when we have a picture of a function like this, this is going to represent what we're looking at. So let's go ahead and read through it and we'll answer the questions one by one. This is the scoring guideline because I already messed up the other one. I printed funky. So this is what we're starting with. So here we go. It says this is a piecewise function. We don't really need to know the value of the function. We're just going to use the graph. And it says g of x is the integral of this function from 2 to wherever I go. So what that means is that this is the area, that g of x is the area under this function, and it starts here at 2. So if I travel in this direction, I consider those areas being added. So this would be areas that was added because it's on top of the graph, and then I would subtract the areas under the graph. So if I travel in this direction, I'm adding those areas. And if I travel in this direction, I'm going to be subtracting the areas. So I would be going backwards and subtracting these areas because it's going backwards. They would be positive, but I'm going backwards. So there you go. So let's see what it asks us to do. It says, does this function g have any relative minimums? Or relative maximums, or neither at x equals 10. So at x equals 10, is this point a relative minimum or a maximum? Not of this graph, not of f, but of g. So is this a maximum of the integral of this graph? Well, we would just take our function and we'd say, you know what? If this is true, if I have that g of x is the integral from 2 to x of this function, then g prime of x would be the derivative of that integral. And the derivative of an integral, that just cancels itself out, and you would just get the function. So you actually get points for that right here. Like you actually get to state the fact. You get 1 point if you state that g of x is worth f of x. If you are able to tell them that this is the key piece of information that you need to know. And then if that's true, well, if it's going to be a minimum or a maximum, then what's going to happen is that g prime is going to have to change signs, right? The slope's going to have to go from up to down or from down to up. So if g prime is going to have to change signs, then that must also mean that f of x has to change signs, right? Because g prime is f of x. And we'll look at, well, over here, f of x is negative, and over here, f of x is negative. So there's no sign change at 10. So I need to explain that there is neither a minimum or a maximum at x equals 10 because since g prime of x is f of x is always greater than 0. It's always less than 0 or negative. So it does not change signs, therefore, neither minimum nor maximum. All right, part B. Part B is going to ask us about inflection points for this graph. So we can go a little bit farther with our information here. If g prime of x is f of x, then to find the inflection points, I need g double prime of x, which means that's actually going to be the slopes of the graph. So the second derivative of g of x is the same as the first derivative of f of x. And since f of x is the graph, then the second derivative of g of x will be the slopes of f of x. So remember, if there's a point of inflection, then we're going to need f prime of x to change sign. So does f prime of x change sign? Well, it says at x equals 4, what's happening? So here's x equals 4. So it looks like f prime is going up, and then it's going down. So I can say, you know what? Since f prime is changing direction, g double prime is changing from positive to negative. So there we go. It has a point of inflection at s equals 4. Since it changes sign, f prime is increasing and then decreasing. Cool. Why does it say f prime? That seems odd. I think it should be g double prime of x equals f prime of x is changing. So f of x is increasing. That means that the derivative is positive. And then f of x is decreasing. That means the derivative is negative. And that's what's happening at that point. All right. Part C, this is where most of the points are. So this gets a little complicated. Part C is going to ask us, hey, find any absolute minimum or maximum values for G. So let's think of what that means. If it has an absolute minimum or maximum values, I have to change two things. I have to check, 1, I have to check the endpoints, and 2, I have to check the critical points. Because if it's an absolute minimum or maximum, that's either going to happen at the beginning or the end of a function, or it's going to happen when the function peaks and turns back around. So it's either going to be at a critical point or it's going to be at one of the endpoints. Well, the two endpoints of this function from -4 to 12 are going to be -4 and 12. So I'm going to have to make sure that I evaluate the function. I have to evaluate g at -4 and 12. So I'm going to need to find g of -4 and g of 12. And the other points that I'm going to have to find are all the critical points. So where are the critical points on my graph? Well, remember, the critical points of g of x are going to be where g prime of x changes its sign. So when the slope of it goes from going up to going down, when g prime changes from going up to going down or from going down to going up, those are the places where there could also be an absolute max. And remember, g prime is f of x. So whenever this function goes from a positive value to a negative value, the slope of g of prime is going from positive or uphill to negative or downhill. So I'm just going to have to look at places like 2, negative, and 6. And these are going to be the places where this function is changing signs. It's going from negatives to positive and then from positives to negatives. So that's why in my solution down below, they have to include these other 2 points, -2 and 6. So now let's talk about how do I evaluate this thing at those spots? Like, how much is it worth? What is g of -4? Because remember, g of x is the integral from 2 to x of f of t dt. So if I say, hey, find g of -4, then I need to find the integral from 2 to -4 of this function. So that's just the area from 2 to -4. So I'm going to evaluate -4 and -2, 6, and 12. So let's go back to here. So here's the -4, here's the -2, here's the 6, and here's the 12. So I need to evaluate the areas. And remember, this function starts here. So if I was to put in a 2 into this function here, I would get the integral from 2 to 2. That means that would be 0. So this whole thing is worth 0 at that spot. So we have all these triangles. By the way, the area of each of these triangles is going to be a 4 by 2. This has an area of 4, 4, 4, 4, 4, 4, and 4. Every triangle has an area of 4. So when I'm going backwards, I count backwards. If I'm below, I count below. So remember, these are below, so these are all -4s. but we're going to be counting backwards, so there's going to be negative 4s. So let's do the first one. Let's find out f of, so we're going to do these with g of, sorry. We're going to find out g of -4. So here we go. Let's do g of -4. I'm going to start at 2, and I'm going to count back till I get to -4. So I'm at 2. So I got to go backwards 4, backwards another 4. I'm at -8. And then backwards a -4. So that's +4. So -4, -8, and then -4, which is going to be a -4. So that's how they're getting these values of -4. So let's try the -2 value. So to find the integral from 2 to -2, I just count back 4 and then back another 4 for a total of -8. That's why my value is -8. Now let's go to 6. So 6 is going to be the same thing, except I'm going forward 4 and then forward another 4 for a total of 8. So my value for that is going to be 8. So 6 turns into 8. And then the last one is going to be this 12 right here. So in my graph, I'm going to start at 2. I'm going to go forward 4, forward another 4, and then down 4, and then down 4. So I'm back to 0. And then I'm going to go also down this last 4. So I'm going to go up 8 and down 12 for a total of -4. So all I have to do now is identify the values. Well, clearly this is the lowest right here. This is going to be the minimum, and this is going to be the maximum. And then all I have to do is state that. So you get a point if you consider the critical values. You get a point if you consider the endpoints. And you get 2 points, probably one for each correct answer. All right, last chunk, last question right here. It says from -4 to 12, find any intervals for which g of x is going to be less than 0. So, I mean, we just did that. We just did the whole function right here. We know that g of x is worth 0 right here. So if I'm counting backwards, I am definitely going to a -4, and then a -8, and then back to a -4. So anything before 2, this is all going to be negative values. Everything from there to there. And then if I'm at 0 and I go forward, well, from 2 to 6, this is all going to be positive, right? +4, +8, and then it goes down 4 and down 4. So by the time it gets to 10, it's back to 0. So everything after 10 is also going to be negative. So those are going to be the 2 things I'm looking at. And down here, you should have them. It's worth 2 points. G of x will be less than 0 from -4 until you get to 2. That was the original point. And then it took all the way to get to 10 for it to get back to the negatives. And so from 10 to 12, it's also negative. All right. Hope that one went well for you. You will definitely see something like that on your AP test. See you later.